Anyway, that was sloppy of me. I should have had this opened all the way to the top of the page. Anyway, we're there now. Hello. This is SAT Worksheet 208 percentages, and by the end of this worksheet, you should have a heads up of what to look out for as far as what type of percentage problems you'll see on the test. There's predominantly two that you just need to be very aware of. Those are percent change problems and find the original value problems. And I'll show you kind of techniques or tactics for each one of these. The one other thing, apart from these two, whenever you're doing a percentage problem that I will caution you on very, very, very hard, is read the problem very carefully and do exactly what it says. And do not take any shortcuts on percentage problems. Really, you don't want to be taking any shortcuts anywhere on the SAT because it's really hard to misread or miss out on something if you're not thoroughly going through each step. But this is especially true for percentage problems. And I'll show you what I mean by that early on in this video. Actually, you know what? Yeah, all right, I'll show you early on. Anyway, first things first, if you have a percentage increase, if something goes up in value, you're multiplying by more than 1. Think of 100% of something as 1, right? Because if you multiply something by 1, you get all of it back. So if something were to go up 25%, you'd multiply by 1.25. Something were to go up 100%, you'd multiply by 2.0 because you're doubling it, which means it's going up 100% of what it was. If something decreases in value, you also have to be really careful of this. If something decreases by 25%, you're not multiplying it by 0.25. That's giving you 25% of what it was. You're multiplying it by 0.75 because if it decreases by 25%, you want 75% of what it currently is. So anyway, something to be very careful of when you read these problems. These two scenarios that I put here are different. For a number to increase by 200%, that's different than 200% of the number. And if you want, pause the video and think about that and see if you know why. But anyway, if something increases by 200%, well, if it increases by 25%, you multiply it by 1.25, meaning you're adding 25% on top of the value. If it increases by 200%, you're adding 100% on top of the value twice. So, right, if it increases by 100%, you'd multiply it by 2.0. To increase by 200%, you're multiplying it by 3.0. Essentially, it's tripling, right? Like if 100 were to increase by 200%, it would become 300. And here's kind of a model here to show you that 10 is original plus 200% of 10 is what we increase it by. Anyway, if we just wanted 200% of 10, we would just multiply it by 2. It would double. Okay, so that's just something to be aware of. Of just simply means multiply. Percent increase or decrease, you have to look at it a little bit more in detail. You need to be careful. Okay, let's talk about the first of the two types of problems I need you to be aware of. In the UK, students seem to be better with this than students in the US. I don't know why it is, but it's a great skill to have. It's understanding percent change. So if something increases or decreases in value and you want to figure out what percent did it increase or decrease by, it's how much it changed by over the original. I always say, I said new minus original over original. My shortcut for that is really just change over original. Easy example, say I have a shirt that's $100. This shirt goes on sale for $70. We know that it decreased by 30%, right? We know that it changed by 30%. And that's easy. Whenever you use 100, it's really easy to see the percent change. But the way you'd actually do this, so this is original, this is new, is you take the difference between the original and the new. Usually you take the absolute value of it, but if you don't know what that means, ignore that for now. But you take the difference between the original and the new, and then you divide by the original, okay? And in this case, that's going to get us 30 over 100, 0.3, or, and that's not 0.3%, 0.30 is really 30%. We move it over 2 spaces, right? 0.30 represents 30%. Anyway, that's percent change. If you want, feel free to pause the video and try this Lester problem out. I'm just going to quickly run through it, and then we'll try 2 problems from the test, because I feel like this concept's fairly straightforward. So Lester buys $450 of stock in a computer company called Pear. Har, har, har. The company's logo is a pear with a bite taken out of it. By the way, I'm not advertising for Apple. Apple and me are not seeing eye to eye right now. My iPhone 7 just went bad yesterday because of one of Apple's updates in planned obsolescence, where the phone just stops working because they want it to. So I have to go out and buy a new phone when I had a perfectly good phone. Anyway, that's a rant. I'll stop. All right. Anyway, Lester stock in Pear increases to $540. What was the percent increase in Pear stock that Lester purchased? Okay. So think about it. The original is 450. The new amount is 540. We want the difference between the two divided by key thing, the original. The original amount was 450. That's what it was originally worth. So we get 0.20. His stock increased by 20%. All right. Let's look at 2 problems from the test. Actually, you know what? Let's look at just one. Problem number 7 looks exactly like every problem we've done so far, so I don't think it's necessarily beneficial to go over it. You can take a second to look at it and read it and try it. I will, I guess, very quickly show how to do it, but I'm not going to go in much detail here. So essentially, the bar graph above shows renewable energy consumption in quadrillions of billion thermal units in the United States by energy source for several energy sources from 2000 to 2010 of the following, which best approximates the percent decrease. So whenever it says percent increase or percent decrease, it means percent change in consumption of wood power in the United States from 2000 to 2010. So 2000 is the original. We're going to 2010. We're talking about wood power. In 2000, wood power is 2.25. In 2010, it's 2.0. The original was 2000, which was 2.25, right? That's the original. So we just went change over original. So 0.25 over 2.25. Okay, that's 1/9. And percentage-wise, wish I could tell you 1/9 off the top of my head. That gets us 11%. It's just 0.11 repeated, actually. So anyway, this one's going to be 11%. Simply just change over original. 8 is a little bit harder. And I'm going to show you how to screw up 8. I'm going to show you exactly how to screw up 8. And this is what the SAT, I wouldn't say they want you to do it, but they're setting you up to do it. So it says a stock increases in value by 7% on Wednesday and then decreased in value by 4% on Thursday. What was the net percentage increase in value of the stock from the end of the day on Tuesday to the end of the day on Thursday? So the mistake a lot of people are going to make is they're going to say, oh, it increases by 7%. Okay, so it goes up 7%. Then it drops 4%. Okay, so it drops down 4%. So really, it's just a 3% change. And they're going to circle C, think they have it, and move on to the next question. And unfortunately, you're just giving that point back to the test. With every percentage problem, you have to go through the steps. You do. You may not understand why when you do it, but you really do. And I'll show you why on this one. Okay, so it's not C, and I'll show you why. Let's just pick the number 100 because it's really easy to use. So let's pretend the original value of the stock is 100. If it goes up 7%, then obviously times 1.07. So that gets us 107. It decreases by 4% in value the next day. Well, it's decreasing by 4% from 107. So we took 7% of 100, which is 7. But 4% of 107 is not going to be 4. It's going to be greater than 4. So we're going to end up going back down towards 100 further than you think. So we're going to take 107, multiply it by 0.96. When we multiply 107 by 0.96, we end up getting 102.72. So essentially, and by the way, whenever you need to do a percentage problem and it feels abstract, always make your number 100. 100 is the best number to use because it's easy to see the percent change off of 100. But essentially, what happened here, we went from an original of 100 up to 102.27. The percent change is just 2.72%. If you are really clever and you don't want to go through those steps, I wouldn't advise it. I would plug in 100 and do it this way. But what you could do is you could say you have an original that is X. It's going to go up by 7%. So you're literally taking whatever the original is, you're increasing it by 7%, and then it's going to go down by 4%. So then you're taking that value, right, whatever value you got when you multiplied X by 1.07, and then you're multiplying that value by 0.96. So it's literally going through the steps we just did here, except instead of using a number like 100, you're just keeping it as a variable X. But if you do 1.07 times 0.96, what you're going to get is you're going to get 1.0272x. In other words, you're going to increase by 2% and change. All right. So anyway, that's number 8. All right. So let's look at this other type of problem. And this problem gets so many people, so many people. In fact, if you want, pause the video and see if you're smarter than the test on this one. See if you can figure out this Katarina problem. I'll say this though, if you are not careful, if you don't go through the steps individually and you take a shortcut, you will almost 100%, percent, packet, percent. But no, I can almost guarantee that you will miss this problem. If not, then good for you. But anyway, I'm going to go through how to mess it up, and I'm going to show you how to get it right. All right, here's how you mess it up. Katarina is a botanist studying the production of pears by 2 types of pears. She noticed that type A trees produce 20% more pears than type B trees did. Based on Katarina's observation, if the type A trees produce 144 pears, how many pears did type B pears produce? So it's a word problem, so it feels like a lot, and it feels like you're kind of trying to hold on to a lot. So a lot of students will say, okay, well, type A pears produce 20% more than type B pears, right? So if type A pears produce 144, then let me just take 80% of 144 and I'll get type B pears, right? Because type B pears produce 20% less. Well, what you're doing here is you're taking type A pears, which is 144, you're multiplying it by 0.80 to decrease the final output of type A pears by 20%. And what you're going to get when you do that, 144 times 0.80, is you're going to get 115.2. So this problem isn't saying what's closest or approximately what were type B pears. It's saying how many. So the minute you get 115.2, you shouldn't say, oh, it just wants me to round down, no big deal. No, because it's not saying approximately or about. You should say, I must have done something wrong here. And then you have to make a decision whether you want to dive deeper or you want to go to the next problem on the test. But based off of how it's worded, they want an exact answer. This A is a trick. Let me explain why. So what we have here is we have a find the original problem. Okay. So if we're thinking about this, so she noticed that type A pears produce 20% more pears than type B pears did. We need to find the original of type A pears, and then we can work from there. So it's one more step than you think. So actually, let me pause this for a second. Okay, we're back. I thought about how I want to explain this. I kind of paused because I realized that I wasn't going to explain it clearly if I kept on going. I know exactly how I want to explain this now. So any find the original problem, you want to write it out algebraically. You want to really think it through and represent exactly what it's saying. The original in this case is B, and I'll tell you why. It's saying that she noticed that type A trees produce 20% more pears than type B trees did. So 20% more than type B gets us what type A produced, which is 144. If you divide 144 by 1.2, you're going to get 120. Okay, so the question you may be asking here is, I don't get it. Why are they different? Why, when you set it up algebraically, did I get a different answer than when I just took 20% away from 144? And I'll tell you why, and I'll also kind of illustrate an example here. So if you think about it, this is taking 20% away from 144, which is, and this is taking 20% and adding it onto 120, because we know B is 120. So taking 20% of 144 is going to be greater than taking 20% of 120. An easy way to think about it is if I just gave the number 100. So pretend that, so we already know the answer to this problem, but pretend that what we had is we had that, say we know that type B pairs is, we have 100. Type A, so I'll put B here. Type A pairs, we have 120. And we know that type A pairs produce 20% more than type B pairs. Well, think about it this way. If we set this up the original way, we would say, oh, let's just take 20% away from type A because that's what we know, and we'll get type B. Well, what you're doing is you're not adding 20% onto the original. You're taking 20% away from this higher number, this 120, instead of adding 20% onto 100. 20% of 100 is 20, but taking 20% away from 120, 20% of 120 is going to be 12. So you're going to end up with 96. You're going to end, or sorry, not 12, double 12. 12 is 10%, right? You double it, you get 24. So you're going to end up taking away 24 rather than the 20. So in other words, you want to write these out. You want to be really careful. When you find the original, always write it out algebraically to reflect the situation given. All right, let's do one of these from the test. By the way, all of that is explained here. Actually, I made some really good problems here. Let's try this bottom one. And you can go through any of these just to kind of get the reps and get a sense of how to write these equations algebraically, these find the original. But anyway, the price of a used guitar is $430, which is 40% less than the same model bought unused. To the nearest dollar, what's the price of the unused guitar? So if we think about it, the price of a used guitar is $430, which is 40% less than the unused or the original amount. So what we're going to say is we're going to say that 60% of the original amount, because that's 40% less than the original, and I'm just going to make the original X. So 60% of the original is 430. Divide by 0.6, and you're going to get that the original is 717. I really encourage you to just run through these 4 other problems above and try them out before you even go into these from the test. Let's see if I circled one to go over. I did. Okay. So I circled 15. So let's take a moment to read it. Again, you can pause your video and try it on your own, but if you keep your video running, we'll be doing this together. So the mean game attendance for a baseball team in 2014 season was 36,500. The 2014 mean game attendance was 104% of, not an 104% increase, but of, so just multiply the mean attendance for the 2013 season. Which of the is the best estimate of the mean game attendance for the 2013 season? Okay, so we're trying to find the 2013 season. We're trying to find the original amount before we increased by 4% or 104% of. So what we would do is we would say that 1.04% of the original amount, we'll call 2013 season X, so that's 2013 season, equals the number we are given for 2014. Now all we have to do is divide by 1.04. So 36,500 divided by 1.04, that gets us, and this one says best estimate, so we don't have to worry about being exact, but what we get is 35,096 and then some leftover bit. So anyway, this one we can safely select that. It's funny though, because if you look at this one logically, from 2013 to 2014, we go up in attendance because we're multiplying by more than 1. We're going up in attendance. So if our attendance in 2013 is 36,500, well, we're definitely not. Or hold on a second. What am I doing here? Let me pause this again. Okay, so what I was saying here is that, and the reason why I kind of stopped was I totally misread and put that in the wrong place. That was not good. So let's put this in the right place. So if we know that the attendance in 2014 is this number, and we know it's up from 2013, then immediately we know it can't be C and D. And if you really think about it, 4% to get to this number, 4% increase to get to this number, going back down, it's not going to bring us down that low. But the safest thing always is to just write out the algebra and find the original. Okay. So the last part of this worksheet, you have mixed practice. And I just want to go over one problem that tends to stump a lot of students. Again, my best advice when you do this mixed practice on percentages is read the questions carefully, map things out. If you're not sure how to get going, you can always plug in the number 100 for your original amount and then do the changes and find what happens. But don't take any shortcuts. Be careful with your steps. And a perfect problem to illustrate that is this next one I'm about to show you. Okay. So if you want to try it, you can pause the video. Otherwise, I'll keep on talking. So Hongbo sold X cell phones in 2013. The number of cell phones he sold in 2014 was 120% greater than in 2013. So let's just start mapping this out. So 2013, he sells X cell phones. 2014 is 120% greater than 2013. So here's where you really have to be careful. Are you multiplying by 1.28 or are you multiplying by 2.28 to get to 2014? Well, if it's greater, it's an increase by 128%. So we think about it, an increase by, so 100% of something, we multiply by 1.0. To increase by 28%, right? If we want 128% of something, to increase by 28%, we'd multiply by 1.28. So to increase by 128%, we're going to multiply by 2.28. That increases by 128%, right? Because 228 is a 128% increase from 100. So interestingly, to get from 2013 to 2014, we need to take X, we need to multiply it by 2.28, and then it says, and the number of cell phones sold in 2015 was 29% greater than in 2014. So then we multiply that by 1.29. That second bit almost gives you a chance to catch yourself, because if you're like, if 29% greater is 1.29, then 128% greater can't be 1.28. It's got to be much higher, 2.28. Anyway, so your answer to this one is D. Okay. Anyway, sorry for the 2 pauses. I wanted to make sure that I was explaining things clearly and fluidly rather than just kind of trying to figure things out during your time. So that's why I decided to pause. But anyway, good luck with this percentage worksheet. And as always, come back for any more insight into other problems on other worksheets. Okay.